Good morning, all. Today we are discuss about the topic is Thevenin's theorem. Okay, what is Thevenin's theorem? Any linear electrical network or complex circuit with current and voltage sources can be replaced by an equivalent circuit containing of a single independent voltage source VTH and a series resistance RTH. Okay, in a complex network formed in the number n numbers of resistance, voltage and current source are mingled in that complex networks. We can reduce that complex network somewhat difficult to normal analysis. We are using Thevenin's theorem. It is reduce the component with a single resistance and voltage source in series with load resistance. This is a statement. What is the step-by-step procedure of Thevenin's theorem by solving any kind of network or circuit? First step, open the load resistor. Any given problem, particular resistor they are asking in that question, power dissipated on the resistor or current flowing through that resistor, what is the voltage in that resistor. Likewise they are asked in the questions. Okay, so that resistor is called load resistor. So open the load. First step, open the load resistor. Second one, calculate or measure the open circuit voltage. This is the Thevenin voltage, and the open circuit voltage is called Thevenin's voltage in Thevenin's analysis. Then open the current sources or short circuit voltage sources in present in that circuit, voltage or current sources. If current source and voltage, both current and voltage sources are there, means open the current source and short circuit the voltage source. Then calculate or measure the open circuit resistance. This is the Thevenin's resistance. First step, we can see first step, open the load resistor. Then calculate the open circuit voltage, that is Thevenin voltage. Second step, uh, the sources, current and voltage sources are same. Two sources are present in a single circuit. We can open the current source and short circuit the voltage source. Then calculate open circuit resistance. This is Thevenin resistance. Okay, now redraw the as it is. Redraw the circuit after calculate the Thevenin voltage and Thevenin resistance. We can calculate the total current flow in that circuit, okay, by using Ohm's law. This is the fifth step. First one, first we can see one example. Find V Thevenin and R Thevenin and the load current IL flowing through the load voltage across the load resistor in the figure. Okay, they are giving 4 resistor and 1 voltage source. The load resistor connected between the point A and B. Okay, first step, open the load resistor. Redraw the circuit, open the load resistor. We should find out. Second step, open circuit voltage. Open circuit voltage, we are using the formula. Okay, what are the formula in this step? Calculate the Thevenin voltage. We already removed the load resistor, figure 1, so that the so become open circuit. It's shown in the figure 2. Now we can calculate the Thevenin voltage, since 3 milliamps current flow in the both 12 kilo ohm and 4 kilo ohm resistor. 12 and 4 kilo ohm resistor this series circuit, the current will not flow in the 8 kilo ohm resistor as it is open. Why? Because of 8 ohm resistor cannot pass the current, because point A and B get opened, so the current not flow in 8 ohm resistor 8 kilo ohm resistor. This way 12 volt appear across 4 kilo ohm resistor, because 12 kilo ohm and 4 kilo ohm resistors are considered as a series resistance, because 8 kilo ohm cannot pass the current, or cannot no current flow on 8 kilo ohm resistor. So 12 kilo ohm and 4 kilo ohm resistors are series resistance. The total current flow is 3 milliamps. 3 milliamps. So the voltage, by using that formula, Ohm's law, uh, the voltage across the 4 kilo ohm resistor is 12 volt, will appear across 8 kilo ohm resistor as well as 4 kilo ohm resistor. Therefore 12 volt across the AB terminals. So the open circuit voltage we can get, that is Thevenin voltage, 12 volt. Next one, next step, that is open the current source or short circuit the voltage source. Now in the problem, we having a voltage source, so short circuit that voltage source. So short circuit and load resistance are open. Now we can measure the open circuit resistance. Resistance. So 8 kilo ohm, 8 kilo ohm in series with 4 and 12, in parallel with 12 and 4 kilo ohm resistors. So we can get the open circuit voltage or open circuit resistance or Thevenin equal to 11 kilo ohm. 11 kilo ohm resistor. So consider as these three circuits or three resistors equivalent is 11 kilo ohm. Now we can draw the Thevenin's equivalent circuit. Thevenin equivalent circuit like this. One voltage source in series with R Thevenin and load resistance. This is the Thevenin equivalent circuit. So we can get the equivalent resistance of 12 kilo ohm, 8 kilo ohm and 4 kilo ohm resistors are 11 kilo ohm. So 11 kilo ohm and 5 kilo ohm. Now connect the load resistors at the point of A and B, in between the A and B. So these are the Thevenin equivalent circuit. Now we can easily find out how much amount of current flow in the 5 kilo ohm resistor by using Ohm's law. IL equal to V by R, total resistance. V by R equal to 0.75 milliamps. Load and load voltage across the 5 kilo ohm resistor is 3.75 kilovolt. 75 kilovolt. So IL, load current IL equal to V Thevenin divided by R Thevenin plus RL. So total resistance, voltage divided by total resistance. So now we can find out the load resistance. Thank you.